Okay, good morning everyone. Now, this is chapter 18, Integration Techniques. Today we are going to learn 18.1 and 18.2. Now, first let me impress you that integration is actually the reverse of differentiation. Now, if let's say we have, for instance, dy dx is equal to 2x. Okay? Now, what does it imply for the function y? We know that if we have y go to x squared, dy dx will be equals to 2x. What about y equals to x squared plus 2? Is the dy dx equal to 2x also? Now, I can also add another function. Y is equals to x squared plus 4. Do you get dy dx equals to 2x? In other words, okay, if I have these two functions, one is a capital F, function x, one is fx, they are related by this, such that when I differentiate the capital Fx, I got fx. Then the fx is also called the derivative of the function with the capital Fx. And fx shall be the what we call the antiderivative of fx, or what we call the integral of fx. Okay, now let us look at this differentiation. If d dx x squared to 2x, okay, we can say that the other way around, right? X squared is the integral of 2x. However, to get the differentiation of 2x, we can also have d dx of x squared plus 7. In other words, x squared plus 7 is also the integral of 2x. Now, therefore, what we can have is that in general, okay, if we have d dx of the big capital Fx plus c, okay, we shall get d dx of big capital of x, because the differentiation of c, where c is a constant, will be 0. So we got this. Now, hence the integral of fx is not unique, okay, but it's in the form of the big Fx plus c, where c is called the arbitrary constant. Now, the process of actually finding the big F plus c from fx is called integration. Therefore, the integral of fx, or this symbol, okay, is something like this, okay, of fx with respect to dx. So we do like that. It's of this form. Now, remember this dx, it's the same as like your ddx, okay? So if we have ddx of x squared plus 7, we say that we differentiate x squared plus 7 with respect to x. So this symbol, this is the integral sign. If we have the integration of fx with respect to x, we are going to have the big F of the function x plus c, where this symbol here is the integration sign, or what we call the integral sign. C is the constant of integration, which is actually the arbitrary constant, and fx is the integrand. Okay, what is being integrated? Okay, or what is being integrated? Sorry. Now, so we have this, basically this formula. Okay, when you actually differentiate this, you notice that we are going to have n plus 1 is actually just a factor. We are going to bring down n plus 1, okay, and then we're going to differentiate, a also is a constant, and then the n plus 1 with minus 1 become x power n. So in this manner, what we can see is that the n plus 1 and n plus 1 is cancelled off, and we're going to get a x power n. Okay, so in other words, this is what we call the formula. Okay, if you were to integrate both sides, okay, integrate, differentiate, we get back what we call the integrand, okay, ax power n dx. We are going to get this formula. Okay, now and another formula that I want to share with you is that if this is just x power n, we integrate with respect to x, okay, we are going to get x n plus 1 over n plus 1 plus c. C will be the arbitrary constant. Now this is required, okay. Without this, you will be penalized. Okay. So what to do with example 1? If I want to find the integral of x squared dx, remember the power will always increase by 1. So we're going to get x2 plus 1 over 2 plus 1. Okay. Now we're going to get, there's a plus c here. Okay. So we're going to get x power 3 over 3 plus c. Now please take note, if I were to differentiate x cubed over 3, I will get back x squared. Of course, the differentiation of c will be 0. Okay. Now in part 2, okay, I were to integrate 2x power negative half with respect to x. Now 2 is a constant. I can actually bring that out. And I normally use a square bracket. Now this is going to be minus half plus 1, minus half plus 1, plus c here. Okay, we are going to have 2 here. Let's minus half plus 1 will be half over half plus c. You are going to get, divide by 2 means times 2, right? So negative 4 x power half plus c. Sorry, there's no negative here. Okay. You can get here. Okay. Now, can I give you some time to do example 2 yourself? In dy dx is given by 3x cubed. What shall we find the y? Okay, in other words, dy dx is equals to 3x cubed. Okay, if I were to integrate this, okay, on both sides, dy dx with respect to x, 3x cubed with respect to x. Now this one will give me y. Okay, so again 3 I can take out. X cubed dx is going to be 3 plus 1, 3 plus 1. So you're going to get 3/4 x power 4. And don't forget plus c. Okay, now remember the plus c is very important. Okay, you may actually put right at the end, but remember to put it. If not, then you're going to get penalized. Okay, now in similar fashion for part 2, okay, we can just jump to this line. So y shall be the integration of this. Okay, so we're going to get half plus 1, half plus 1. So this is going to be x power 3 over 2 over 3 over 2. So we're going to get 2/3 x power 3 over 2. And remember, plus c. Okay. For part 3, if you just have 5, so y, if the dy dx is 5, so y shall be 5 of dx. Now this is going to be 5x power 0, right? So in similar fashion, this is 0 plus 1, 0 plus 1. So this is going to be 5x plus c.